Suppose you want your airplane to climb as fast as possible. How would you make it do this? You might think that you want to climb with a lot of airspeed. But to do that, you're going to have a pretty low pitch angle, since if you have too much of a pitch angle, you're going to lose that airspeed. So you might also think you could try to climb with a very high pitch angle to go up as much as possible. But again, if you do that, you're going to lose a lot of airspeed and you will not be going up very fast. So the way to climb as fast as possible to get the best rate of climb is somewhere in between the two. Enough of a pitch up angle that you're actually going up a reasonable amount, but low enough of a pitch angle that you still have a decent amount of airspeed. So the airspeed that gives us this happy medium is called Vy, or the best rate of climb airspeed. That's the airspeed that gives you could think of it as the greatest upward indication on your vertical speed indicator, the greatest rate of climb in feet per minute or whatever units you're using. So that's why I drew a little stopwatch here, because this is the airspeed that lets you gain the most altitude in the least amount of time. And this is what we normally use to climb out after takeoff for a normal takeoff and climb, because our concern there is to get some altitude in case of an engine failure so that we have room to maneuver and find a place to land safely. So we want to get up to a safe altitude in the least amount of time possible. So that's why we use the best rate of climb speed for that. But we're not always interested in gaining the most altitude in the least amount of time. Sometimes we're interested in gaining the most altitude in the shortest possible distance. So imagine we're taking off from a runway that has an obstacle at the end. Maybe there's some trees at the end of the runway. So after lifting off, we need to get up and over those trees before we get to them, obviously. And we don't really care how long it takes to do that. It's not so much a matter of time, it's a matter of distance. There's a fixed distance between us and where the obstacle is, and we need to be above that obstacle after we've traveled that certain distance. Whether that takes 10 seconds or 30 seconds or a minute, we don't really care. So we don't use the best rate of climb speed when we are climbing to get over an obstacle. We use something else called Vx, the best angle of climb speed. So the best angle of climb gives us the greatest gain in altitude per unit of distance traveled rather than per amount of time. So because it's per unit distance, I've drawn this little ruler here. So Vx is the airspeed that's going to give us the greatest gain in altitude in feet per unit distance traveled forward, whether that's feet or nautical miles or whatever. And you can see from the drawing here that that is a steeper climb angle than for Vy. So Vx is going to be slower than Vy because we've got a greater pitch up here. We're going to be going at a slower airspeed. So it's not getting us up in the shortest amount of time, but it is giving us the greatest gain in altitude for every foot we travel forward. So we use this for clearing obstacles. If we're taking off from a short field that's got trees or buildings or whatever at the end of the runway, after we lift off, we pitch for Vx, the best angle of climb, to get up in that amount of distance we have before we reach those obstacles. Once we're well clear of the obstacles, normally then we lower the nose and let the airspeed increase to our Vy for our normal takeoff and climb. The way I remember the difference here is that X has more angles in it. The actual letter X has more angles in it than Y. So that is the best angle of climb speed, Vx. So the airspeeds that you're going to find for Vx and Vy in your pilot's operating handbook for your airplane are normally given under standard conditions at sea level. And those airspeeds are going to change with altitude. So here I have a little graph with Vy and Vx airspeed down here and altitude up here. So Vy decreases with altitude and Vx increases with altitude. And eventually they meet, and the point at which they meet is called the absolute ceiling. That is the point at which the airplane cannot climb at all above that altitude. So just keep in mind that Vx and Vy do change. A lot of the time when you're in flight training, you'll just use the published Vx and Vy and not really worry about them changing too much. Maybe if you're at an airport that's pretty high elevation, maybe you'll knock a few knots off of those speeds, but typically you just use the published speeds for sea level under standard conditions and assume that they're close enough. But you should be aware that they do change with altitude.